We are Team Lima. This is our project Sustainable Gaming, and this is our game, Gnome and Sky. Current games promote unsustainable modes of thought. For instance, Minecraft, which encourages you to strip mine, to kill every animal you see, and to destroy everything with TNT. We wanted to create a game that promoted sustainable decision-making. Not one in which sustainability was the win condition, but one in which the player would be actively encouraged to think about sustainability. We used Godot, the open source game engine, and C#, and of course Git and GitHub as repository managers. So the project. We wanted to create a way to promote sustainable thinking. So we decided to take the biodiversity out. The player would start in an abandoned alien planet with no life and an unbreathable atmosphere. They would have to explore the planet in order to find fossils, which they could then take back to their home base. When they brought these fossils back, they could turn them into useful items, such as vials of bacteria, seeds, and eggs. The vials of bacteria would allow them to make their atmosphere breathable. The seeds would allow them to create beautiful landscapes and to have a sustainable food source. And the animals would allow them to increase the biodiversity around them. By having the player create the world around them and to create the biodiversity, they would value it, and therefore would be promoted to destroy the living things they just made. This is an example of how the world changes as the player advances.
So as regards with the technology actually behind it, how do we create a random world? We'll start with a more simple example of generating a two-dimensional random world. So we start by generating random, evenly spaced points on the x-axis between 0 and 1. We interpolate with something called a smooth step polynomial. If we then expand this to a two-dimensional height map for our 3D world, we then get very rounded, unnatural-looking terrain, which is not what we want. The solution is to use octave noise. We start with a high amplitude, low frequency noise. We then begin to halve the amplitude, double the frequency, and we keep doing this, and we add all the resulting noises together. In our project, we do this 16 times, and the result is something like this, in which we have much better defined mountains, features, and hills, but also the details of rocky outcroppings. Another issue with the terrain generation is how do we generate the starting base? We need a flat place to put it down. To do this, we take the original noise function used to generate the world. We then take a constant flat noise function. We weight these two noise functions using a sigmoid function based on the distance from the origin. The result is effectively the exact same terrain, but just with a flattened area at the origin that we can happily just plonk down the player's basin. Generating ice lakes is actually quite a simple process. We just have a fixed sea level in air quotes. Any block below the sea level will simply get set to be ice, generating these large lakes that the player can obtain water from. Another interesting algorithm is how we handle grass and tree spreading. So we start with dots, or in our case trees, and we apply something called Bridson's Poisson-Dis sampling algorithm. We then look at a radius r and a radius 2r from a random tree. We generate a point within those two radii. We then look at the radius r of all other existing trees, and we detect if this point conflicts with that. In this case, it doesn't. So we now know that we are allowed to now put a new tree there. What this allows us to do is randomly spread trees, but spread them evenly so we don't have them so bunched together. So that was just a brief overview of some of the technology behind our project. There's obviously a lot more behind it. I hope you all had a chance to have a go and see the game in action in the demo. Thank you all for listening.